Hello Python students. In this tutorial, we will see nested loops. We have studied two different types of loops, while and for, and nesting can be done using these two loops in any order, as in for inside for, while inside while, for inside while, or while inside for. All four different variations are possible with respect to nested loops. Now we will see four different examples where these four different types of nesting is used. Problem statement 1. Find all prime numbers less than the entered number. Here, as per the test cases, we have to give one number as an input and the Python program should return all the numbers which are lesser than the entered number, and at the same time the numbers has to be prime numbers. For example, if the input number is 9, then the expected output should be 2, 3, 5 and 7. Similarly for 15, where it should be 2, 3, 5, 7, 11 and 13. For input 3, it should be only 2. Whereas for input 2, the Python program should not print any output because there is no prime number which is lesser than 2. Same for last test case where input is 1. Now let's look at the Python code which represents this problem statement. In this code, in the first line we will accept the number from user using input function, then convert it to integer and store in a variable named num. If the number is greater than equal to 2, we will simply print 2, as we know is the only even number which is prime. Hence, we will have this particular if condition specific to number 2. If entered number is greater than equal to 2, print 2. And we are using this end space over here so that every time print function will print a number in the same line. Then for numbers 3 onwards, we are using this for loop which will iterate from 3 to the entered number. We will set the flag to false. Now, as we want to find all the numbers which are lesser than the entered number, we will use this particular I as the input for next particular loop. Therefore, the range for inner for loop will be from 2 to I. The outer loop will iterate from 3 to the entered number, and each of those numbers will be later on checked whether they are prime or not using the inner for loop. Therefore, we are doing this particular operation I modulo j, and if the result is 0, then we are setting flag to false. That means there exists at least one number which is j in this case dividing I. Hence flag will set to false and we will break the loop. This particular break statement will break only the inner loop, because if this condition satisfies, we can term that particular number as not prime. If this flag never becomes false, then we will set it to true, saying it is a prime number. And then at the end, outside the loop, we will check if flag is true or not. If flag is true, we will print that number as prime once again using end, which will print it in the same line. Now let's try to execute this code using some of the sample test cases. Enter a number 9, output is 2, 3, 5, 7 as expected. 15, 2, 3, 5, 7, 11, 13. 3, output is only 2. Now we also have to check the last two cases which are different as compared to the previous test cases. enter a number 2. Now that is the incorrect output because the problem statement says find all prime numbers less than the entered number, and the expected output for this test case is no output. That means we have made a mistake in the Python code. Now let's check what the mistake is. In the first if condition, we are checking whether number is greater than or equal to 2. As the problem statement says, the prime numbers less than the entered number. Therefore, we should not use equal to sign over here. It should be number greater than 2. Now let's try to execute the same code again. Enter a number 2, no output, which is expected. Next, enter a number 1, no output. Once again, that was the expected result. The idea behind introducing this particular problem statement was to demonstrate how two for loops can be nested. This was possible because the range function was possible to define in both the cases. In first case, the range function was going from 3 to the number, whereas in second case it should go from 2 to I, whereas I represents the value of the outer iteration. Let's look at a different kind of nesting using while loops. Find the total profit or loss of each trader working in a trading firm. Information regarding number of traders and number of transactions is unknown. Now if you look at the test cases, first we are getting employee ID of the trader, then we are getting different trade values either in terms of profits or loss for that particular trader for whom this particular trade ID is. We are stopping accepting these trade values when we receive 0. As we go on accepting and calculating the total trades for each trader, at some point we will receive an employee ID as -1, and that's the place where we should stop the execution of our program. Which means now we require two loops. One loop which will accept the values for all these traders and it will stop when we reach to -1, and one more loop which will accept all these trade amounts for each trader until it receives 0. Therefore, a while loop is more suitable solution because we cannot predict how many traders will be there. At the same time, we cannot predict how many transactions will be there as given in the problem statement. So let's try to write a Python program which contains two nested while loops, one for number of traders and second for number of trades. First, we will accept the employee ID. Then, if employee ID is not equal to 1, keep accepting the information for new employee every time. Then we will accept the trade value. We will declare one variable profit underscore loss as 0. This particular variable will be used to calculate the final amount of trade irrespective of whether it's a profit or a loss. Then if trade amount is not equal to 0, then we will continue to accept the trade amounts from the trader. Before that, we have to add the previous trade value into this particular variable profit underscore loss. This loop will continue until we receive value 0, which is the stopping condition for the trade values. Once that happens, we will print the result of that particular trader using formatted printing like this, where this represents a variable employee ID and this represents variable profit loss. At the time of printing, the values which are stored against these variables will be replaced and then the statement will be printed. Once that is executed for one employee, then we will accept the employee ID of next employee until we get -1 as an input. Similarly, for that new employee, all these steps will be executed and the final profit or loss value will be printed. Now let's try to execute this Python code for the given test cases. This will be the output of the given program with respect to given test cases. First, we entered the employee ID SJ323. We got the expected output 57558. Then the program continued because we entered PK874, not -1. We kept entering the all trade values and it stopped when we entered 0. We got the output which is 10853. Then similar thing happened for this employee VM578. Then for AT194, and then at the end when we entered the employee ID as -1, the execution of this Python program stopped. This is exactly what the given problem statement suggests. Now let's look at a different variation of nested loop. Third problem statement: find the day-wise total rainfall for the entered duration of time, for example week, month, etc. Now as per the test cases, we have to enter number of days and then for each day from 1 to that number n, we have to accept different values of rainfall for that particular day. Then we have to keep accepting these numbers till we get -1, and the output should be the total rainfall of that particular day. Therefore, for day 1, the total rainfall is 10 plus 15 plus 19 plus 5, which is 49. We will keep doing this for 7 different days. Hence, we have to accept these values 7 different times, means 7 iterations. As this number is fixed, we can clearly decide that for loop is a better suited option for this outer loop, whereas the inner loop should accept these rainfall values till it gets -1. Therefore, while loop is a better suited solution. If you look at day 5, only entered number is -1, which means there was no rainfall on that particular day. Hence, the total is 0. Now let's try to write a Python program which represents this problem statement using nested while inside a for loop. We will accept the number of days from the user. Then we will run the for loop from 1 to days plus 1. It's 1 to days plus 1 because we are calling first day as day 1 and the last day as day 7 instead of 0 to 6. Declare one variable total and initialize to 0. Accept the first value of rainfall for day 1. Then keep accepting such rainfall values for each day until we get -1. Keep adding these rainfall values into variable total. Whenever we get -1, we will stop the inner iteration, which is this for loop, and then this particular print statement will print the total rainfall for day. 0 will be replaced by I and 1 will be replaced by total. Therefore, in case of day 1, it should print total rainfall for day 1 is 49. Let's execute this particular Python code with the given test cases. Enter the number of days 7, then rainfall for that particular day 10, 15, 19, 5, and to stop it -1. Hence the total rainfall for day 1 is 49. Then similar for day 2, which is 56, day 3 303, day 4 39, day 5 as we have directly entered -1, which means there was no rainfall on that particular day. Hence day 5 0, day 6 194, day 7 99, and that's the place we will stop because the outer for loop was executing from 1 to days plus 1, which are total 7 iterations. Now let's see the remaining variation of nested loops. Find the length of longest word from the set of words entered by the user. Here we have to enter one word at a time till we get -1. Once that happens, then we have to print the length of the longest word, which means we have to write one loop which will accept these words one at a time. Then the inner loop will calculate the number of letters or number of characters in that particular word, which is nothing but the length of the word. Every time a new word comes, we have to compare the length of that new word with the previous maximum value, and if the current length is greater than previous max, then we will update the max variable with the current value of that word length, which clearly indicates that the outer loop should be while loop, because we cannot predict how many words user will enter every time. For example, for test case 1, 2 and 4, user is entering 3 words, whereas in test case 3, user is entering 2 words and 5 words in test case number 5. Now let's look at the Python code representing this problem statement. Accept a word from the user, declare one variable called max length initialized to 0. Till the entered word is not -1, we will continue accepting words. Then for each word, we will count the number of letters or characters in that word, which is nothing but the length of the word, using a different variation of for, which uses the for each feature of for loop, which we have seen earlier, which means we will iterate over the input word using a letter or a character at a time. Therefore, count should be incremented every time the value of variable letter is updated. Once this particular loop ends, we will compare the value of count against current max length. If count is greater than max length, we will update the max length with the count. When we get -1 as an input, we will stop the for loop and print final output, which says the length of longest word is the value of variable max length. Now let's execute this particular code using the given test cases. Enter a word IITM, enter next word which is online, then degree. In order to stop accepting -1, then the length of longest word is 6. For second test case, Bachelor of Science, the length of longest word is 8. Then next test case, longest is 13, longest is 12 and the last longest is 11. Based on these 4 problem statements, we can say that all different types of nesting is possible using for as well as while loop. It can be while inside while, for inside for inside while, or while inside for. As per the requirement of the given problem statement, we will decide which nesting method is more suitable. Thank you for watching this tutorial. Happy learning.